All right, we are go over discussion menu page 20. It's week 1, resonance structure. The one that I'm drawing on the board is question D, so it's question 4. What should we do first? Once you see negative, okay, come back to the table. The table I went through in the class. Do you think we are missing anything here?
2 lone pairs or the lone pairs?
Yeah. We're talking about the lone pair. So let's quick review on this carbon. This one. Okay. I'll write in pink. Okay, this carbon, which is bond to, if we read everything else, okay, there should be pair of lone pair. And should be bond to a third thing.
Hydrogen.
Yes, there's a missing hydrogen. We actually didn't draw them out. Okay. This carbon, which we'll redraw them in a different color. This one. It's green. We know it's double bonded to whatever below, but here there is also a missing hydrogen that we didn't draw them out. Are you cool with this? Yeah. This purple one. Since it's basically symmetrical. Are we cool with those? Okay, this carbon. Alright, if we're gonna draw resonance structure on this one, might make your life a little bit easier. But think about the step. We're going to start with lone pair or negative or double bond. Here is a lone pair that we can play around with. Change it orange. Okay. Are we all good with we're going to start here? It looks like that's the best place to start because it has a negative. Okay. Once it starts to pull, can we stop here? No, because it's going to make this green carbon 5 bond. So the only possible choice in this case is to push it to here. Alright? Okay, I'm going to erase the original one. So because I will use more colors, so whichever was not affected by the orange, I'll use blue. So I can use more color in the next step. Are we good? So far so good? And if we keep moving, this negative, orange negative, can keep pushing. It's a better place that I draw them here. I'll draw them on the lower side, so I cannot push. Are we cool with so far? Which means you can keep playing around with that. Keep do the same thing. Am I good to not draw the rest? But I think pretty much you just keep pushing until it starts to repeat. Are we good?
So you could keep going until it starts looking like the original one,
Yeah.
Okay.
Yeah. There will be.
and that's when you know when to like kind of stop.
Stop. Yeah.
Okay.
For this one, that's one. For this one, that's one. Specifically. Since we will go over another one, I'll show the other one. Okay. Where are the decision making points? One, I cannot stop with one arrow here because my carbon has 5 bonds. But if it's not going to make my carbon 5 bonds, let's say here is a positive, my carbon is happy, then I can stop here. Or I can stop at a place that's basically meets up one of our requirements on the table. That you feel like, oh, look, I just pushed this carbon into one of something that you're familiar with so far, and that's a good place to stop. You are not required to draw a lot of resonance structure. I think this practice is more of like be familiar with this is correct. 5 bond is not acceptable. Are you good? Okay. Also, a quick practice on who is major.
They're all equivalent.
Yeah, they're all equivalent. Why they're all equivalent?
Because none of them fulfill any of the rules.
Yeah, because this all 5 are carbon. Your negative is just falling on any of them. There's no much difference.
And if, say, like one of them had a minor, how would we determine it? I'm a little confused with how to determine the minor.
Okay, not this one because they are the same. We probably will do that here.
Why?
Okay.
Oh, why are they all equivalent?
Because all of them are carbon.
Okay.
And then we said basically there's all 5 structures. If you draw them now, probably going to be 5. If you just look at a different direction, it's all 1 negative with 2 double bond. It's just a different carbon who's taking the negative, but they're all carbon. So if you look from this perspective, it's actually the same one as before.
Mhm.
Are you good?
And so, say if we like had an oxygen.
Okay, oxygen is going to be a different scenario.
Right.
If there's an oxygen, the negative should be on the oxygen, and that's going to be the major.
Okay.
Yeah.
Perfect.
Okay. Good.